Hi everyone, this is Unit 11, Lesson 5, and today we're going to talk about reference angles and exact values. So some of this will be a review of what we already learned, but it is a little bit confusing, so it'll be good. So problem number 1, we're going to sketch and label theta in standard position if theta equals 7 pi over 6. Alright, so let's draw an xy axis. Now 7 pi over 6, let's change to degrees. Okay, change to degrees. So if I have 7 pi over 6, to change radians to degrees, I multiply by 180 over pi. So now the pi's are going to cancel. 6 is going to go into 180 30 times, and 7 times 30 is 210. So I have 210 degrees. Now I need to figure out what the reference angle is, because how do I draw 210 degrees? 210 minus 180 is 30, so that's my reference angle. So if I'm going to draw this, let me grab the purple here. So I'm starting here, okay, and I'm going all the way. So 180 would be the opposite side, so it's 30 degrees past 180. All right, so this will be my angle going this way. This will be theta. All right. Question 2, if sine of theta is less than 0, so that's basically telling me that sine is negative. And remember, all students take calc. Sine is negative in the third and fourth quadrant. And tangent of theta is greater than 0, so that means tangent is positive. So all students say, so tangent is positive in the first and the third. So what do those have in common? The third. A reference angle is the acute angle formed by the terminal side of the angle and the x-axis. Angles in the first quadrant are their own reference angle. Quadrantal angles are 0, 90, 180, 270. They do not have a reference angle because they are either on the x or y axis. So quadrant 1, 60 degrees, I have my own reference angle. So this is just a little picture. Quadrant 2, reference angles 120 degrees, also has a reference angle of 60. All right, so let's write it as I'm going through, and we'll write underneath. So the reference angle for quadrant 1 is 60 degrees. It's its own reference angle. 120 degrees lands in the second quadrant, but it also has a reference angle of 60 degrees. How do I get that? 180 minus 120 is 60. Quadrant 3, so 240 degrees. 240 minus 180 also has a reference angle of 60 degrees. Okay, so it's the closest to the x-axis that you can get. And then 315 degrees, if I do 360 minus 315, that's going to be 45 degrees. So that one's different. All right, let's flip this over. Unit circle again. So I have this all filled out because we already talked about this yesterday. But basically, remember, if you know the rules for the 30, 60, 90, so here's my 30 degree angle. Okay, so 30 degrees. And remember that cosine is your x and sine is your y. Okay, and all I'm doing, all of these angles are just a variation on 30, 60, 90. So 30, there are my points, radical 3, 2, and 1/2. But notice, I'll highlight them for us. Any reference angle that's also the same as 30, so 150 degrees has the same reference angle as 30, is also radical 3 over 2, 1/2, but the signs are changing. How are the signs changing? The signs are changing on whether they are positive or negative in that quadrant. All students take calc, that's what I'm remembering. But all of these have a reference angle of, so 210 has a reference angle of 30. 330 has a reference angle of 30. So they're all going to be a variation of radical 3 over 2 and 1/2. All right, and then the 45s, I'll do those in blue. Okay, so the 45 degree angle, and I'll highlight that in green, are going to be some variation of radical 2 over 2, radical 2 over 2. So 135 degrees also, but sine Sine is positive, but cosine is negative. That's why it's negative radical 2 over 2. 225 has a reference angle of 45. But in the third quadrant, cosine and sine are negative. And 315 degrees also has a reference angle of 45. And in the fourth quadrant, sine is negative. So you can see that the y-coordinate is negative. And then the last one is all of these have a reference angle of 60. So 120 has a reference angle of 60, so they're all going to be negative 1/2 and radical 3 over 2. 240 has a reference angle of 60, and 300 has a reference angle of 60. So the degrees are there, the radians are there, and then you can see how those are all the same, and all that's happening is that the signs are changing. So if you know the rules for the 30 and 45 and 60, then you're all set. All right, using the unit circle, how are the coordinates of 30, 45, and 60 determined? Well, we were looking at them up there, but remember this is a 45, 45, 90 triangle, this first one right here, because you could see that those sides are congruent, so it's an isosceles right triangle. So these sides are the same, and how do I get the other side? Well, I can just call this x, and I could use the Pythagorean theorem. 1 squared plus 1 squared equals x squared. So 1 plus 1 equals x squared. X squared equals 2, x equals the square root of 2. Okay, so you can see my sides, 1, 1, radical 2. So the sine of 45 is opposite over hypotenuse, 1 over radical 2, but then I rationalize that denominator. 30, 60, 90, well the sine of 30, as long as you have this memorized, sine of 30 is 1/2. So across from the 30 is 1, the hypotenuse is twice that, and then I can do the Pythagorean theorem to find that missing side. 1 squared plus x squared equals 2 squared. I'm just showing you how you could do it if you did not know it. So this is radical 3. Okay? This right here is pointing out, what do you notice about the points located at 30 degrees, 150, 210, and 330? Why do you think this is happening? Well, if we look up above, I had all of those highlighted in yellow. They were all some combination of radical 3 over 2 and 1/2. So the 30 degrees was radical 3 over 2, 1/2. I'm just going to write them right here. The 150 degrees was negative radical 3 over 2 and 1/2. The 210 degrees was negative radical 3 over 2 and negative 1/2. And the 330 degrees was radical 3 over 2 and negative 1/2. Okay, they all have a reference angle of 30 degrees. They're all going to be some form of radical 3 over 2 and 1/2. The positive and negative depends on the quadrant that they're in. Okay, and what's that quadrant going to be? Remember, all students take calc. So that will determine that. And remember, the x and y, x is your cosine and y is your sine. So there we go. What do you notice about the points located at 45, 135, 225, and 315? They all have a reference angle, and I pointed these out, of 45 degrees. So again, cosine is the x, sine is your y. They're all some form of 1 over radical 2, 1 over radical 2, but I do rationalize that denominator. So they're all going to be radical 2 over 2, radical 2 over 2. Just the signs depend on the quadrant that they're in. All right? All right, so let's look at this. Let's fill in the exact values for this chart. We already did this earlier. So if I have my 30, 60, 90 triangle, the side across from the 30 is 1, the hypotenuse is 2, the side across from the 60 is radical 3. And if I have my 45, 45, 90 triangle, these sides are congruent and this one's radical 2. So sine is 1/2, Cosine of 30 is radical 3 over 2. And tangent is 1 over radical 3. But when I rationalize that, that's radical 3 over 3. 45, we just did that, is 1 over radical 2. I rationalize that, though, and it's radical 2 over 2. Cosine is going to be the same thing, radical 2 over 2. And tangent is 1. 60 is radical 3 over 2. Sine of 60, radical 3 over 2. Cosine of 60 is 1/2. And tangent is radical 3. All right, to find the exact value at any angle, you're going to sketch the angle, determine the reference angle, calculate the trig function value of that reference angle, and then determine the sign, if it's going to be positive or negative, remembering that ASTC. So all of them are positive, sine's positive, tangent's positive, cosine is positive. All right, so how does this look? Sine of 150 degrees. Well, sine of 150 degrees is the same thing as sine of 30 degrees. Okay, because 150 degrees, I start here. This is going to be 90, so it's going past 90. This is 150 degrees. It has a reference angle of 30 degrees. All right, and sine of 30 degrees is just equal to 1/2. In the second quadrant, which is where I am, sine is going to be positive. Right? Tangent of 5 pi over 6. Well, let's change that to degrees. So I multiply by 180 over pi. Pi's cancel. 6 goes into 180 30 times. 5 times 30 is 150 degrees. All right. 180 minus 150. Oh, reference angle of 30, just like I did on the other one, but this time I'm doing tangent. All right, so here's my 150, but it has a reference angle of 30. I am in the second quadrant. In the second quadrant, tangent is negative. So tangent of 150 is the same thing as negative tangent of 30. Don't forget the negative, because I am in the second quadrant and tangent is negative in the second quadrant. Well, tangent of 30, if I looked at my chart up above, is radical 3 over 3. All right, so this is just going to be negative radical 3 over 3. So I'm finding exact values right now. Cosine of negative, cosecant, sorry, of negative 135. So I got to do 180 minus 135 is 45. So I have a reference angle of 45 degrees. So the cosecant of negative 135 is the same thing as the negative cosecant of 45. I am going to be in the third quadrant, okay, because I'm going this way. So I'm starting here, but I'm going this way, negative 135 degrees. Okay, is the same as the reference angle. So let's see. In the third quadrant, cosecant is negative, because cosecant is just the inverse of sine. All right, so third quadrant, it's going to be negative. It's the inverse of sine. So let's find out what sine is. Negative sine of 45 degrees. Well, sine of 45, look up here, sine of 45 is 1 over radical 2. Let's not rationalize it, because I'm going to have to flip it. Negative sine of 45 is negative 1 over radical 2. But cosecant, I have to flip that. All right, so negative cosecant of 45, I'm just going to flip this, because it's the reciprocal, is negative radical 2 over 1. So therefore, negative cosecant, there's a lot of thinking going on here, or I should say cosecant of negative 135 is negative radical 2. Okay, and one more left. Let's do another one where I have to switch it to degrees. So I'm going to multiply by 180 over pi. Pi's cancel. 3 goes into 180 60 times. 5 times 60 is 300. Well, 360 minus 300 is 60. So that's my reference angle. All right, so it looks basically, I just want to change the color here so I can draw it. So I'm starting here, but I'm going all the way around like this. That's 300 degrees. So it has a reference angle of 60. All students take calc. Cotangent is the inverse of tangent. Tangent is negative, so I'm in the fourth quadrant. Negative in fourth quadrant. Okay, so negative tangent of 60 is negative radical 3, but then I have to flip that. So negative cotangent of 60, I'm going to flip that, is negative 1 over radical 3, but then I have to rationalize that. So I multiply top and bottom by radical 3. So my answer is negative radical 3 over 3. Definitely a lot to think about. The rules again, you're going to sketch the angle, determine the reference angle, calculate the trig function value at that reference angle, think about whether it's going to be positive or negative based on what quadrant it's in, and then of course if it's a reciprocal one, you got to flip that. So we'll practice that all tomorrow.